Hello viewers, in today's session we are going to discuss a very important and conceptual problem from differentiability of functions, right? So viewers, we have already discussed a lot of problems in our earlier videos regarding the differentiability of functions, and we have seen that how to find the right hand derivative and the left hand derivative of functions at a given point, right? So here in this class we are going to solve this problem where we are given a function f of x that is equal to x raised to 4 over 3, and we have to show that this function is differentiable at x is equal to 0, right? So by differentiability of a function, we mean that the slope of the tangent to the curve at the given point it exists, right? And moreover, the tangent should be unique, right? So here we have to show that the derivative of this function at x is equal to 0, it exists, right? Because we are to show that this function is differentiable at x is equal to 0, right? So in order to show that this function is differentiable at x is equal to 0, we have to find the right hand derivative and the left hand derivative of this function at x is equal to 0, and we have to show that the right hand derivative and the left hand derivative both exist, they are finite, and they are equal to each other, right? So let us separately find out the right hand derivative and left hand derivative of this function at x is equal to 0. So the right hand derivative is defined by this limit, that is the limit h tends to 0 f of a plus h minus f of a divided by h, right? Where h is a very small quantity, that is infinitesimally very small, and this point a is the point where we have to find out the right hand derivative. So here we have x is equal to 0. So we have a is equal to 0. So now we have limit h tends to 0, and here we have f of 0 plus h taking a is equal to 0, and here we have f of 0 and divided by h. So we can now write limit h tends to 0, and we have f of h minus f of 0, right? So f of 0 can be obtained by taking x is equal to 0 in the given function. We have f of 0 is 0 raised to 4 by 3, that is simply 0, right? So here we have 0 and here we have h. So now we have limit h tends to 0, and f of h is obtained by replacing x by h. So we have h raised to 4 over 3, and here we have h. And now by making use of the laws of exponents, so here we have h raised to 1. So taking h raised to 1 to the numerator, we have 4 over 3 minus 1. So this is the limit h tends to 0, h raised to 4 minus 3 over 3. So we have limit h tends to 0, and this is h raised to 1 over 3. And now taking the limit, that is h tends to 0, here taking h is equal to 0, we have 0 raised to 1 over 3, that is equal to 0, right? So the right hand derivative of this function at x is equal to 0 is 0. So we can also write it like this. We have r for the right hand derivative, then f prime of 0 is equal to 0, right? Now let us find out the left hand derivative. So the definition of left hand derivative goes like this. This is limit h tends to 0, f of a minus h minus f of a divided by negative of h, right? Now taking a is equal to 0, we can write limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h, and we have limit h tends to 0, and this is simply f of minus h, because 0 minus h is minus h, and f of 0 is equal to 0. So here we have 0, here we have minus h. Now we have limit h tends to 0. F of minus h can be obtained by replacing x by minus h. So we have minus h raised to 4 over 3, and in the denominator we have minus h raised to 1, right? So again, applying the laws of exponents, we can take minus h raised to 1 to the numerator. So we have minus h, and we have 4 over 3 minus 1, right? So this is limit h tends to 0 minus h raised to 4 minus 3. This is 3 times 1 is 3 over 3. So this is limit h tends to 0 minus h raised to 1 over 3, right? So now taking h is equal to 0 here, this expression goes to 0. So here we have 0, right? So the left hand derivative of this function at x is equal to 0 is it is denoted by L, f prime of 0, that is also equal to 0, right? So we can see that both the derivatives, that is the right hand derivative and the left hand derivative, exist. They are finite and both are equal to each other, right? So the right hand derivative is equal to left hand derivative, and it is equal to 0, right? So we can safely say that f prime of 0, that is the derivative of this function at x is equal to 0, is equal to 0, right? And this function is said to be differentiable.